So we're back for properties of exponents 2. When a number is raised to a power and then that quantity is raised to another power, the result is the same as if you raised a number to the product of the two. So the example here I have is 8 to the second power raised to the third would be equal to 8 to the 2 times 3, which would be 8 to the sixth power. To take a look at how that works, 8 to the second power means 8 times 8. But 8 to the second power is being raised to the third power. Raising something to the third power means multiply by itself 3 times. So really this means 8 times 8 times 8 times 8, and then lastly times 8 times 8 again, which gives you a total of 2, 4, 6. You're raising 8 to the sixth power. Okay, so if you have any kind of a number raised to a power and then that quantity is raised to another power, multiply the two exponents. So in the example here, x squared raised to the y power is equal to x to the 2y. Our next property is if we have a fraction, a over b, and we raise that quantity or that whole fraction to the c power, we can simply put the fraction in the numerator portion to the power and the denominator portion to the power. And an example of that would be 2/3 raised to the second power. Well, 2/3 raised to the second power means 2/3 times itself, which is 2/3 times 2/3. In the numerator, 2 times 2 would be 2 squared, and in the denominator, 3 times 3 would be 3 squared, which would give you your final answer of your 4/9. Going over here to the second example, 2x to the third power over 3y to the third power would mean we'd take the quantity 2x raised to the third power. Following the property that we did previously, that would mean take the 3, which is the exponent, and deliver it to the 2 and to the x. So we have 2 to the third times x to the third. We're looking right here right now. And we could also take the 3 from the 3y and make it 3 to the third times y to the third. Simplifying, 2 to the third power is 8, and 3 to the third is 27, giving you a final answer of 8x to the third over 27y to the third. If you raise a number to a negative power, it would be the same as doing the reciprocal and raising it to the positive power. So for example, if I were to do 5 to the negative second power, that's really the same as 1 over 5 to the positive second power, which would be also equivalent to 1 over 25. A good way to illustrate this is to start with numbers like, let's suppose I was going to do 5 to the third power divided by 5 to the fifth power. Well, this is just the subtracting exponents property. So this would end up being 5 to the negative second power. But a different way to look at that would be, this is the same as 5 times 5 times 5 in the top, because it's 5 to the third power. And the denominator is 5 times 5 times 5 times 5. I wish this would write a little neater, which would be 5 to the fifth power in the bottom. If you look at what cancels here, 5, that 5, and that 5, leaving you 1 up top and 25, or 5 squared, in the bottom. So that's a nice way to see how those negative exponents kind of play out. In number 9, the raising a number to a negative power is equivalent to the reciprocal of the number raised to the opposite power. So for example, if I had a over b to the negative c, that's equal to b over a to the c, which is b to the c over a to the c when we combine the last property as well. So let's do an example. 2/3 raised to the negative third power would be equal to 3 over 2 raised to the positive third power, which would be the same as 3 to the third power over 2 to the third power 3 times 3 is 9, times 3 is 27. 8 times 8 is, 2 times 2 is 4, times 2 is 8. So this final answer would be 27 over 8. And lastly, just want to talk about raising number to fractional power. If we raise a number to a fractional power, that is the same as saying the nth root of the number. So for example, if I said 25 raised to the 1/2 power, that's the same as saying the square root of 25, which would be equal to 5. But if I said 8 raised to the 1/3 power, that's the same as the cube root of 8. And that means what number multiplied by itself 3 times is equal to 8, then that answer is 2. So when we see fractional values like 1/2, that means square root, 1/3 means cube root, and you can evaluate from there. Now when you're raising to a fraction that doesn't have a 1 in the top, treat that number as the power. So for example, if I had the number 8 raised to the 2/3 power, that would be the same as having the cube root, because the bottom numbers are 3, the cube root of 8, and then the quantity of that squared. So we know the cube root of 8 is 2. Raise that to the second power, this final answer would be 4. Now another equivalent way to do that problem would be to do the cube root of 8 squared. So the squared can happen either to the 8 or outside after the cube root has been done. So this would be equal to the cube root of 64, which we think about what number of times itself 3 times makes 64. It's 4 times 4 times 4, so this would be 4, which is the same as we had previously when we did the problem the other way. Okay, so let's take a look at one more of those. Let's suppose we had a number like 16 raised to the 3/4 power. That would mean the 4th root of 16, and then take that result and raise it to the 3rd power. And again, the bottom numbers are roots, the top numbers are powers. So the 4th root of 16, what number times itself? 4 times makes 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. It looks like it would be 2. Raise that to the 3rd power. 2 to the 3rd power is 8. So 16 raised to the 3/4 power is 8. And that's all for right now. Thank you for listening.